Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah, assalatu wassalamu ala rasulillah. Today we are going to discuss about electric field. We have already discussed the concept of Coulomb's law or Coulomb's force. Now let us start our new topic, electric field. And what is electric field? To understand this, at first we must revisit our Coulomb's force. And what is Coulomb's force? Coulomb's force is a force F given by 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. And what this force says? It says that if there are two charges Q1 and Q2 and there is a distance r between the centers of these two charges, then there will be a force, whether attraction or repulsion. Magnitude of that force will be given by this expression. Now we want to study or discuss electric field. Electric field. To discuss electric field, we have some assumptions. There is a charge capital Q. Mostly we denote this charge with capital Q, and this is called source charge. And source charge is a larger charge, and around source charge there is another charge, say small q, and this charge is called test charge. Source charge doesn't move, that is, it is fixed in its place. But test charge can move, that is, it is not fixed at its place. Now this source charge generally taken positive, and this test charge can also be taken as positive. And the other thing is that the magnitude of source charge is much greater in comparison of test charge. Why these assumptions? Because we are going to discuss electric field, and electric field is associated with source charge, and test charge is just for the purpose to know how much force this charge exert on the test charge. So in visualization, if we imagine what is an electric field, then we say that imagine Q to be placed here, and around the source charge Q there is a region. That region may be of any nature, any shape, any size, depends on the magnitude of Q, obviously. And another charge is outside of this region. This is our test charge. Now if this test charge is outside of this region, then obviously there is no interaction, neither force of attraction nor repulsion. As we have already mentioned that our source charge is positive and also our test charge is positive. So when this test charge is moved inside this region, what happens? There comes a force, that is Coulomb's force, and that force repel our test charge. It means that the force of repulsion or attraction in the case of a negative test charge, the force of repulsion or attraction can occur inside this region. Outside of this region there is no force felt by this test charge, but inside this region there is a force. So around source charge there is a physical region, vicinity, around which another charge can feel the force of attraction or repulsion. This region is called or is known as electric field of source charge. So remember one thing, that electric field is generated by the source charge, and test charge feels that electric field and according to its sign get attracted or repelled in the field. In our case, this source charge is positive and our test charge is also positive, which has been moved from outside of this region inside of this region. Now let us talk about the force which comes into play here, and that force is Coulomb's force. F equals 1 upon 4 pi epsilon naught q into q by r square. What is electric field? This region is the electric field, and this test charge experiences a force. So we can say that force experienced by a unit charge, or say unit positive charge, will be given by F by Q, and here we can say that Q get cancelled. So we are left with 1 upon 4 pi epsilon naught capital Q by r square. What this equation says? It says force in per unit charge, that is, this quantity is known as electric field. So if we want to define mathematically, this is the mathematical expression for electric field, and if we want to define mathematically electric field, what we can say? Force experienced by unit positive charge in the vicinity of a source charge at a distance r is given by this expression, and this is electric field. That is, electric field is just a force experienced by a unit positive charge. So if we have another charge, suppose we have a charge q dash, then if we want to get force experienced by this charge, then just we multiply q dash with electric field and we get our force. This is another expression. So if we know electric field and we are given a certain charge, if we multiply our electric field with that charge, it gives us Coulomb's force between the source charge and the other charge. So this expression enables us to calculate the force which another charge feels inside this vicinity. Once we are given with the value of electric field, the force experienced by another charge can easily be calculated.